Okay, let's talk about these triangles under constraints. And what that word means is saying that they're giving us specific side lengths, in this case, of how to create these triangles. Okay, and we're going to try and figure out whether these side lengths are going to make a triangle or not make a triangle. So let's look at our first example. So all they're telling us here is that we have side lengths of 4, 6, and 8. And you can see them over here. These are our little pieces. If I was having you do this in class, I would have actually given you these pieces to help explore this on your own. So we're just going to talk through it since we don't have that option. So you can see we've got our side length of 4 here, and then we've got 6, and then we have 8. And you can clearly see this makes a triangle, okay? Not really too crazy. You might be like, Miss Lynch, duh, we know that. Well, let's take a look at another example, because that's really what this is all about, is looking at and seeing all these different situations. So right now, this triangle has a base of 4, but what if we change it up? What if we decided to do a base of 8 instead? So like this. So we still have 4, 6, and 8 as our side lengths, but now we put 8 on the bottom. Well, if you think about it, this is really the exact same triangle. All we did was rotate it, right? It's kind of like we just plopped it down, flipped it down, right? But it still has the same side lengths. It's still the same shape. It's just rotated. We could even flip it another time and have 6 be the base if we want. But regardless, you can see that these 3 side lengths, when we put them together, do in fact make a triangle, right? The only difference now is that we got 4 over here, 6 over here, 8 on the bottom. Okay, that's really the only difference. Again, you might be like, Miss Lynch, duh, this seems obvious. Well, stick with me a little longer. What if we change up the side lengths? So let's try this example. Now we have a side length of 4 and 6 still, but now we have a base of 12. Well, now look what happened here. There's no triangle. Even if I were to rotate this all the way down flat and this one all the way down flat, do you see how there would still be a gap? Right? 4 and 6 are never going to meet up. They're never going to touch. The 12 is keeping them apart. So these 3 side lengths do not make a triangle. No triangle. They won't. They don't meet up. There's always a gap, right? No matter how much we bend those 4 or rotate those 4 and 6, there's always going to be this gap. So these 3 side lengths don't make a triangle the way the last ones did. Let's look at one more example. So now we have, again, a side length of 4 and 6, just like before, and now we have a base of 10. Well, if you look at these, it looks like they're just about to touch, right? Like if I rotate this all the way down and all the way down there, they will touch, but they're not going to make a triangle. They're going to end up laying perfectly flat, creating a line. Okay, I know that's not perfectly straight, but you get my point. They're going to create a line rather than a triangle. So I want us to look at our 3 examples here. So we had a triangle that had the side lengths of 4, 6, and 8, and that one did make a triangle. I'm going to put a check mark because it did make a triangle. Our next example was 4, 6, and 12, and this one did not make a triangle, right? It was like just a little too short. Even if we rotated it, they were never going to meet. So this one did not make a triangle. Then our last example on this slide was 4, 6, and 10, and again, it did not make a triangle. They ended up making a straight line, right? If it folded down, it would make a straight line. Well, you might be like, okay, Miss Lynch, what does this matter? Why do we care? Well, this is how we can learn whether or not side lengths will create a triangle or not, because we can't just pick numbers arbitrarily. They do not always make a triangle. So I'm going to give you some hints as to figure out why these made a triangle or not. So if you think about the 4 and 6, how those stayed the same the whole time. Well, let's think about those numbers together. So if let's look at this example where it created a line. You might be noticing the connection that 4 plus 6 equals 10. And that makes sense why it didn't make a triangle. It made a line because 10 would equal 10, right? If I laid down these flat, it'd be the same length. That's exactly why it didn't make a triangle, because 4 plus 6 was exactly 10, so those were never going to meet until they were laying flat. If I go back to this example where it didn't make a triangle, you can see that we got, again, 4 plus 6 equaling 10, and that's not as long as 12, right? So they're never going to be able to meet because 10 is never going to have enough to meet before we get to that 12, right? 12's keeping those 4 and 6 too far apart, so they're never going to meet up because 10 is not long enough compared to 12. Our first example, though, did make a triangle because we had, so again, the 4 plus 6 makes the 10, and so that this time is longer than 8. So that's why the 4 and the 6 met up, because these two sides put together were longer than the third side. So that is what is creating them to meet up, versus in these two examples. These two, when we added the shorter sides together, they were too short to meet up before they had the longer length. And then on this one, they were exactly the same, so when they did meet up, it ended up with a line instead of a triangle. Okay, so that's kind of the idea we want to think about. If you add those two shorter sides together and they are longer than the third side, then it's going to make a triangle. If you add them together and they're shorter or equal, it's not going to make a triangle. So I know I just kind of briefly explained the rule there. We're going to continue to work on this rule throughout the week, but that's a bit of an overview to get you started. So what I want you to do is I want you to look at these examples, and so you have 3 side lengths here. And so you want to think, will they make a triangle or not, using the idea that we just talked about. So start with the shorter sides. See if when you add them together, they're going to be longer than that third side. If it is longer, it'll make a triangle because they're going to meet in time. If it's not longer, so it's equal or less than, that means it's not going to create a triangle because they're not going to meet in time. So I'm going to answer this on in the next video for you. Right now, I just want you to think through these 4 examples on your own and see if they're going to make a triangle or not. So use the ideas we had from this video to give it a go. Good luck, and then check the video in the next section.